All right, we're going to finish section 1.3, and we were in the middle of talking about circles when we left off. Oops, went a little too far. So our fourth example is to find the center and radius of this particular circle, and then to graph the circle. So what you'll notice if you take a look at this equation that we had, I'll post this on our next slide so we can reference it, is that on the first example, there isn't anything grouped with x or grouped with y. By default, what that actually means is that this is in essence x minus 0 squared plus y minus 0 squared. You don't necessarily need to write that out, but just be aware that that's what's going on. The 16 would then also be 4, the quantity 4 squared. If you write it in that way, sometimes it helps to identify the center and the radius. So the center then from this identification would be 0, 0. And the radius would actually be the 4 because the radius squared would be the 4 that's being squared. Now in terms of a graph, we can plot the center then as being this location. And then the radius needs to go 4 out in each direction from the center. So all of those are going to, those sort of marks are going to be part of my circle, and we'll see if I can get a circle drawn well through those points. I'll shift mine here in just a second. Well, that's not too bad. That would be my circle. Center 0, 0 and radius 4. Now on part B, you'll notice this one is not, in the same form at all that we would need to identify, but it's not too bad. If I take this piece right here, this piece right here, that's what I meant to do, and I add that to the other side, then I would have x squared plus, and then y minus 3 squared equals 9 squared. So my center, I won't rewrite this one this time, but my center would be 0, and then this piece right here, and I use the opposite sign because it's y minus k, so the k would be the 3, y minus 3, so 0, 3 would be my center. And then my radius is not 9, so be very careful with that. That's a common mistake. It is 9 according to the way I wrote it. Let me fix that. I threw an extra square in there. It's not 9. It's actually 3 squared on the right-hand side, so the radius would be 3. So in my circles graph, I need to make sure I get the center in the right place. The center is 0, 3. So 0 would be how far left and right I went, and then up 3. 1, 2, 3. So this is my center, and then my radius is actually 3 as well. So I will go left, right, up, and down 3 from this location. So 1, 2, 3 to the right, 1, 2, 3 to the left. I've got 3 down, already puts me on the x-axis, and then 1, 2, 3 up. So I've got these points. Remember, you're going left, right, up, and down from the center that are going to be where I'm trying to go through. I'll draw this in my hand just so you can see what yours will look more like. It won't look perfect, but you have this as your basic idea for the center 0, 3 and your radius of 3. All right, so as you would imagine, both of those were actually given in a pretty nice form, at least for being able to identify the center and the radius, and they don't always actually look like that. So if they're given in a form where they don't look like this, you may have to do something called completing the square. So I'm going to do an example with you of what completing the square looks like and how to process through that. In order to do completing the square for our purposes of what we're doing, you'll want to have the x terms first, the y terms second, and all the constants on the right-hand side. Okay? Now, as we're noticing, this one's already given in that form. If it weren't, we'd simply rearrange. I've got the x squared minus 8x, and then I'm going to leave a blank spot. And then I have y squared minus 10y. Again, I'm going to leave a blank spot. And I've got equals negative 5 on the right. Now, completing the square is the process by which we're able to take what we're given and we're able to find a perfect square number to go in each of those blanks that will create a quantity when we're done that will match our formula, basically. We want something that looks like this. I want something that is perfectly squared. So that's what completing the square is sort of going to do for us. And the key to completing the square is to take the linear term coefficient. So, well, and then that would be in this case the 8. It doesn't really even matter if you use the positive or the negative part of it. It doesn't make any difference because you're going to square it here in a minute anyway. So you're going to take that b value, you're going to divide it by 2, and you're going to square it. So in the case of our negative 8 divided by 2 is negative 4. Negative 4 squared is 16. But if I add 16 to the left, I have to also add 16 to the right. So they're compensated, right? They're balancing. All right, our linear term in the y values is negative 10. So again, negative 10 divided by 2 would be negative 5. Negative 5 squared would be 25. If I add it to the left, I also have to add it to the right. Now, the right-hand side, I'm going to move this key part over here. The right-hand side is the easy side because you're just adding all those quantities together. So negative 5, positive 16, and positive 25 is actually 36. So you have 36 on the right. On the left side, there's some beautiful things that are going to happen, right? Of course, the whole reason that we chose the numbers we did is because they factor beautifully. And in particular, they will factor into a quantity squared. In both cases, I mean, like that's why we chose what we chose, is because they will factor in this way. In particular, you will have the first terms, singular part, so x. And in the end, you'll have this piece right here, right, the 16 in our case, square rooted, which would be a 4. So this is x plus 4. Same thing on the second one. You'd have y, and then the square root of 25 would be 5. Now, it does need to have the sign that matches the middle part, so I screwed that one up on my x's. Let me fix it. This would be x minus 4, because the 8 in the middle is negative. And it will be x minus 5, because then 10 in the middle is negative 10. All right, so now if we were asked to do that, I'm not asked on this one, I will be in a moment, but if I were asked to do this, I could find the center. It would be 4, 5, like the ordered pair 4, 5. I could find the radius. It would be the square root of 36, which is 6. Okay, so we can find all of that because we completed the square to get it into this standard form. So we're going to do one that's going to be a little bit trickier in the next one because there's some fractions involved. All right, so just like on the last one, though, what I said I wanted is I wanted all the x terms first, which I have that, and in order, squared and then singular, squared and then linear. I want the y terms second, which I have that, but then I want the constant terms on the right, so I do need to move the 3/4 over to the right-hand side. All right, so I've got sort of everything where I wanted. I wanted x squared minus 3x, and then I need to leave a blank spot, right? And then I have y squared plus 2y, and then I'm going to leave a blank spot. And then it equals 3 over 4. All right, so our middle term is now the key, right? What I said over here, the key item here. We're going to take that middle term's coefficient, so negative 3. Negative 3 divided by 2 would be negative 3 halves. And negative 3 halves squared, well, we'd square the top, that's a 9. We'd square the half, which is going to give me a 4. If I add 9/4 to the right, I have to add 9/4 to the left, I have to add it to the right. The other piece is easier to work with because it's a 2. 2 divided by 2, of course, is 1. 1 squared is 1. So if I add 1 to the left, I have to add 1 to the right. All right, if I add 3/4 and 9/4, that would be 9, 10, 11, 12/4. 12/4 is 3, and then 3 plus 1, of course, is 4, so the right-hand side is 4. On the left, I will have each of these squared. Remember, that's the whole reason that I chose the values I did. The linear part at the beginning is x. And then I just need the square root of the 9/4. Well, the square root of 9 is 3. The square root of 4 is 2. So this is plus 3 halves, and it is not plus. I did it again. It's a minus because it needs to match the sign on the middle term. And the middle term sign right here is a negative. So we do need a negative on ours. So x minus 3 halves. On the other one, I've got y. And then I've got the square root of 1, which is 1. And this one actually is positive because there's a plus sign in the middle on the linear term 2y. All right, my directions actually said to find the center and the radius on this one. So my center will be the opposite sign of the x minus 3 halves. So that's 3 halves, comma. And the opposite sign on the 1 would be a -1, so there's my center. And then my radius is the square root of what's on the right-hand side, so the square root of 4, which is 2. And we did that, of course, using completing the square. All right, the last pieces that we're going to do is a little bit about lines. The standard form of a line, we saw this in our last lesson, was ax plus by equals c. We even talked about it a little bit. There are a couple conditions. A and b cannot both be 0. One of them actually could be 0, and c could be 0, but not a and b both being 0 will create a line. We're going to graph this line 5x minus 2y equals 10, and it specifically tells us to use x and y intercepts. Obviously, there's lots of ways to graph a line, and I'm going to show you several of them throughout Chapter 1. But one of them actually is a very nice way of graphing it with intercepts, and in particular, to graph with intercepts means to graph the points when x is equal to, whoops, I meant to write 0, and find out what y is, and then when y is equal to 0 and finding out what x is. So in particular, if I took this equation, then I let x be 0, I'd get 0 at the beginning, and I'd have -2y equals to 10. So -2y equals 10, and dividing by -2, y would equal -5. So my intercept on the first one is 0, -5. On the second one, if y was, oops, let me erase that. If y was equal to 0, this would go away, and I'd be left with 5x equals to 10. And again, dividing by 5 at the beginning of the x then would be x equal to 2. So x is 2, y is 0. So using those 2 points, just like using any 2 points, but using those 2 particular points, we should be able to graph our line. So I have 0, -5. So 0 means how far left and right I go. It goes 0. And then -5 means down 5. So here's my first point. The other point was at 2, 0. So 2 means I go to right. 0 means I go up 0. So there's my second point. And then I can connect this together with a line. And it would look something like that. I actually do need the arrows on the end of the line to indicate that it continues on from there and it's not just a line segment. So this would be a rough graph anyway, an approximate graph of the line 5x minus 2y equals to 10. Now we're going to do another example. This one's more difficult just because the numbers end up being larger. Directions are the same. We're going to graph it using the x and the y intercepts as a point of reference. So if I let x be 0, then I'm going to get 1/3 y equals 600. And I'm going to have to multiply by 3 to solve for this, right? Or divide by 1/3. Y actually equals 1800. It's a very, very large number. So our graph, of course, isn't going to be very large, but it's going to be an approximation graph. And then on the other one, if y is 0, so if y is 0, I end up with 1/2 x left because this zeroes out on the y term, equals 600. And again, if I multiply by 2 to isolate my x, I end up getting that x is 1200. All right, so these are my 2 ordered pairs. I'm just going to do approximations for what they are, but I'm going to label them. So if x is 0 and y is 1800, then that means I'm going to go 0 left and right. I'm going to go up 1800. So I'm just going to mark this and call it 1800. And then the other point was 1200, 0. So 1200 would tell us I go right 1200. Again, I'm going to mark it as 1200. It should, in fact, look like that distance to 1200 is less than the distance to 1800. Just, visually, that seems like a reasonable assessment to make. And it looks pretty good on what I've drawn. And then, of course, we're going to go up 0 from there. So our points are actually, our intercepts are actually these 2 black dots that I just drew in. And then we're going to draw a line between them. That was not a good line. Let me try one again more time. Okay, that's not too bad. I think I can shift it over just a little bit, be better. Okay, and then we would draw arrows on the ends of this line. So we have these arrows drawn indicating that the line continues in both directions. All right, one last thing in this section we're going to talk about is horizontal and vertical lines. Horizontal and vertical lines are the ones that go straight up and down. That's vertical. or straight right and left, and that's horizontal. An acronym that I have found to be very useful with horizontal and vertical lines is HOIVUX. You may or may not have heard of this acronym, but it's kind of a nice one. H stands for horizontal, and then likewise, of course, V stands for vertical. So let me tell you what the OY, O-Y, and the UX, U-X, stand for. So H stands for horizontal. The O is actually the number 0. It stands for the word zero. Zero slope. So horizontal lines have 0 slope. And they have equations y equals a number. Vertical lines have undefined, which is not 0, it's undefined slope. And they have equations x equals a number. Okay? So if you ever see x equals 5, that has to be a vertical line. If you ever see y equals 7, that has to be a horizontal line. If you ever see a vertical line drawn, the slope is considered undefined. If you ever see a horizontal line drawn, it's considered to have a 0 slope. All right, so we're going to do a couple of examples. We're going to graph x equals -3. And so x equals -3 would be the VUX part, right? So this is a vertical line through -3. So if x is equal to -3, then we're going to go left 3, and we're going to draw our vertical line right here. This would be the line, x equals -3. Our second line that it references is y equals 2. So again, this is the HOY, H-O-Y, part of HOIVUX. Y equals a number means it's a horizontal line through y is 2. So y is 2 means we go up 2. And our horizontal line, I'll do it in a different color just so that it's clear that it's something different. It's right here. Again, arrows on the end of it. And this would be the line y equal 2, and it is a horizontal line. So this horizontal line has 0 slope. My vertical line has undefined slope.